Good evening, everybody. I'm recording this. Good. So you are welcome once again. What is the? I've opened too many things. I can't even see the. Oh, check. How many things did I open? Okay. This. So nobody asked question about what we did yesterday, so that we can clarify those areas. You have questions. So nobody asked because I know that yesterday people were tired because it was late. So we may not remember of any question. So especially the person that watched something. You don't have question? Dr. Fatima, at least you watch it. Where is it? Where is this thing not showing? Dr. Fatima, watch it. Okay, yes, yesterday we discussed up to where we needed to run analysis, which is what we are supposed to do today. We should start from there today. I don't know. Remember we talked about chi-square distribution, different type of chi-square distribution. We said that it depends on degree of freedom. The distribution shape depends on the degree of freedom. That shows that it's a family. Apart from the fact that it's, you know, chi-square is very interesting. Apart from the fact that different chi-square, you know, the shape depends on the degree of freedom. Even many statistics follow that path. Many statistics follow chi-square distribution. Many statistics, and we were making mention of them. Pearson, you know, even McNemer chi-square, McNemer Bowker, though it's the same Pearson that I use for goodness of fit. We have Kuka-Wallis chi-square. The worst statistic we use, logistic regression chi-square. Chi-square for homogeneity, for meta-analysis. Chi-square Monte-Hessig chi-square for stratified analysis. This is an example. I just want to quickly clarify something before we move ahead to run the analysis. I tried to, you know, somebody was asking about the continuity correction or gate correction, just the logic, because sometimes until you see something, a picture to conceptualize, you may not understand. So, you know, the more you get familiar with it, the more you understand. Even we also that we're talking, it's over time that we get to understand some integrity. I still want to understand other things, more things also. So, you know, when we say, I don't want to go back to probability distribution, because go and watch the video on probability distribution. We talk about different type of distribution. The probability distribution there is either discrete or continuous. And under discrete, we have a lot of them. Binomial is just one of them. And under continuous, normal distribution is just one of them. Chi-square is one of the continuum. F distribution, T distribution, those are continuum normal probability distribution. But the discrete probability distribution, what makes something discrete that it is possible for you to know the different, all the categories of the value of any variable that follow discrete probability distribution. Like sex now, we know that male or female. Even if you have hermaphrodite, yeah, okay, male or female hermaphrodite, you know it. So there are many things. You talk about many things like even the like SK 1 to 5. You know that there are 5 values. So many things that you can, any categorical variable follow discrete probability distribution, because you can know the different number of categories and now calculate their probability. So the distribution, the value, when you now list the values of all the possible values and their probability, all the possible values of a variable and the probability of all the possible values, you list them. That's the probability distribution. So for the discrete, it is easy, you can know all. But for continuous probability distribution, since you don't know all the possible value of a continuous variable, so you cannot know all the probability. You cannot know. So it's difficult for you to have a table. Say this is the table of all the probability for continuous probability distribution. But God makes you can plot a graph. When you plot a graph, you can say area under this graph is 1. The total area is 1. You can use that. And when you plot a graph, the graph for probability distribution is called probability density function. So that is the way out for the continual probability distribution. You can see plot graph for discrete probability distribution. When you plot their own graph, the graph alone is not the only one that even you can have the list of the possible value and state it. So the binomial, when we say binomial, there are only two possible outcomes, either yes or no, male or female. So they usually call it failure, success or failure. It's not as it may be success or failure, it's whatever. If you say sex follow binomial distribution, there are only two possible values, either male or female. If I'm interested in knowing the probability of female, so the probability of female is the success, that of the male is failure. If I'm interested in the male, so that male is the success and the so it's just to say, you know, they are complementary. If you say that, oh, the probability of teenage pregnancy, then the probability of not having teenage pregnancy also is the opposite. So you know the other one from 100% or from 1. So can you see? So any of them go. That is why if you say the proportion of female in that training, the proportion of female in that training is 60%. A sensible person will not say, what is proportion of male then? They say the other one is 60. You know the other when you remove 60 because you either male or female. So now the binomial distribution now is just looking at any categorical variable follow it. Even you say that where there are some of them that are more than 2 categories, but you can choose one category and compare with the rest. So it has followed. So any categorical variable follow binomial distribution because even like ethnicity now, you can say, oh, Hausa and others, Igbos and others, Yoruba and others, Ishekri and others. So if you do that, it has followed binomial distribution. So when you plot the graph for that binomial, you look at something like this, more like it's not a smooth graph. Though let's say does this block at the graph for it, you know, different maybe you different scenario. If you maybe you take sample many times, this is the way it will be. You take sample many times, you are looking at the probability of success. If let's say I'm sampling people now, I want to know, I'm sampling many times to know what is probability percentage of female. I'm sample now. So when you sample many times, you see various values. If you now plot it, it will give you this one step. It's not smooth. So if you draw this smooth line, which is the normal for normal distribution, you know that even all these the district probability distribution, if you take sample many time, we have already talked about that. Under sampling distribution, it will follow normal distribution also. If you take many time, even thing that doesn't follow normal distribution will follow normal distribution. So you will be surprised also. If you say you want to know the proportion of female, you take sample many times, you now arrange the value like this. It will follow what you are seeing. You take sample many times, it will follow. But the issue is that if you want to make it smooth, it cannot. Can you see? You see. Now if you go to the next slide, because we know that this is not actually smooth. If you look at it now, for it to turn to normal distribution to make it continuous, you can just see a space now. Look at this blue area now. I want to consider this part of it. If you look at it, there's a space here. If you superimpose this normal distribution, look at the space here. Look at the space here. So the intelligent doing that's okay to just make it like that. What you should do, you want to remove this edge here and put it here so that it fill the space. You fill that space. So this one that comes out, how do you use it to fill this way and fill this way to become like this? You see, if you step further and remove the upper end, you remove 0.5, you add 0.5 on this side. It will give it that. That's the logic behind doing that continuity correction. Because chi-squared distribution is a continuous probability distribution. And what you are using it to, to look at association between variables that follow district, they are categorical. They follow binomial, as I have said. All the categorical variables follow the binomial. Even if it's not only one category you have, you can have one category and compare with a collapse order. So that is the logic origin. This one is still explaining the same thing. So, you know, I promised, is it Emmanuel that asked that question yesterday? And that's why I said, okay, maybe make me to concession. That is the logic behind what Yates did. But some people are criticizing that there's no need. After all, if you look at it, there's no difference, much more difference between the value of the uncorrected and the corrected. And after all, if I do my work and it's significant, if the uncorrected is not significant, I will not take the way. If the corrected is not significant and the uncorrected is significant, I will take the not corrected. I don't want I will take. Somebody is asking a question. So I just go over that. So please put yourself, if you know that you are not talking, and please Usman. So just mute yourself. It is when you want to talk, you mute yourself. I think we talk about all these other ones. Let's quickly run the analysis. So I think I'm not the one that will run the analysis yet. I will tell you what to do. I want to stop sharing from here. I want somebody to share. Just open your SPSS. People that have downloaded. Who just finished installing now? Is it not Cargo? Is it Emmanuel Akago that just installed now? Emmanuel.
Yes, sir.
Are you not the one that just finished installing?
Yes, I'm the one.
It's very simple. So what you should do, you know where you put, you see something now. You know where you the data set I sent, because I sent all the data set for practice. You know where you know where you put them. Don't even open SPSS now. Just go to that place. Just open. You see what will happen. Just open. Just open as if you are going there and share with us. You go there. You go and click on it. You open that version 25 for you automatically and share it and bring the data out. So where you put the data file you want to use now is socioeconomic status. There's a data file, socioeconomic status. You are welcome. Go now. Socioeconomic status. You know where you should just go there. Please don't waste time. Because I want it to be participatory. That data we use, for example, is under
right?
Yes. Have you reached the file? Share with us now. Click on share screen. Share screen, please. You know, when anything you are doing, I'm not doing personally, we want people to see what you are doing, to learn from it. Share your screen, yes. Anywhere you are. That's great. So, which version is this? So, is it this version? Anyway, let's see. Double click on it. Okay. Oh, that's the way it operates. Okay. Click on that. Okay. Click. You see it will open. Can you see? It opened SPSS for you. Normally, it's supposed to open the data file. I don't know.
Yes, it's supposed to do that. Should I open it with the previous version?
Don't waste time. Don't waste time on that. Since it has opened the SPSS, you want to open the existing file, just say open. You say you want to just click on open. Not another. Okay, you look for the place here. So look at where the folder is. Next one now, it will take you to that folder. I don't know why you people like putting something in desktop. Desktop, look for where somewhere your document and put something there. Okay, go and click on it again. I thought you have seen it. Okay. Okay, socioeconomic status. Double click. The document is already in use by. You have opened it. That's no wonder. Please, you know what? You can stop sharing. First, stop sharing. You will see. Or look, share again. Can you see? Yeah, can you see it has opened? Expand it.
Hello, sir.
Yes.
Hello, sir. Please, how do I copy the crack file, sir?
Okay. I've sent it to you now. You saw it in your mail.
Yes, sir. I've seen it, sir.
And just right click on it. I just copy. Right click and copy. That thing I sent to you. Just right click and just don't even your this thing, just right click and copy.
Yes, I've done that, sir.
And were you not following the step we did the other time? I don't want to, because I want us to start our.
Yes, I was unable to locate the particular folder I was supposed to paste it inside, sir.
You are drawing us back now. If you type on your start bar, type IBM. When you type IBM, it will give you, you'll see it will come up the version 25. Okay, you know,
Yes,
three things will come up. There is license, there is wizard. It's not the wizard, it's the application itself. The one that doesn't have license and wizard. You now right click on it. Have you done that? Are you there now?
Yes, sir.
You right click on the one that doesn't have wizard and doesn't have license. Can you see that one?
Yes, I've seen it, sir.
Right click on it. Now you see, click on open file location. Have you seen file location?
Yes, I've seen it, sir.
Oh, click on it.
Yes, sir.
I'll click on the file location. Inside the file location, see, right click on that same, not the other one, that same 25 that have no license and wizard. Right click on it.
Yes,
have you done that?
Yes, sir.
Okay. Open file location also. That one is up now. The file location is up. Open file location. Can you see?
Open file. Yes, I've done it, sir.
It will open something. Right click inside that thing. You open to your right click now. Have you right click?
Yes, sir. I've done it, sir.
Paste now.
It's all right, sir.
It will now. Have you pasted it?
Yes, I've done it.
It gives you something. Replace something. Did you see something like that?
Yes.
Click on that replace. Does it? Have you clicked?
Hello, sir. I mean, hold on, sir. I've not been.
Yes,
I've done it.
Have you clicked? It will say continue. Don't skip. Did you give you something that you should continue or skip something?
Yes, continue.
Continue. Click on continue. That's the end. So you are finished. So you are finished in solid. Let's continue. Now, we want to look at, so the socioeconomic status, now we are looking at the sex and employer. So we want to do the CASPER, go to analyze. Dr. Akagu, go to analyze then. Under descriptive statistics, go to descriptive statistics. Then you see cross tab, go to cross tab. Anything you want to do about, it's only situation when you want to do, anyway, most of the chi-square is under cross tabulation. It's only few you go and do under non-parametric, even though it's a non-parametric test. Okay. Now move your, what is your outcome variable? What is your exposure here between sex and employment status? Because it's test and employment status. Which one should be the outcome? Which one?
Again, the network is unstable here, please.
So
do you want to answer? You want? Okay.
No, wait.
I ask you.
Yes, sir.
Okay.
I'm just asking generally. Akagu is saying something. You said?
Okay, stop. Okay.
Akagu, you said something.
Hello, sir.
Yes.
I think the network is unstable. Can you come again, please, sir? I didn't hear what you said.
Okay, don't worry. Just put sex on the row.
Sex will be on the row. Okay, yeah.
Sex is the outcome.
Okay.
Is the exposure now.
Employed.
We put it on the row.
Employed.
Then the employed. Click on exponent education. Employed. Then move it to the column. You have not clicked on it. If you click on it, it will highlight. Click on it now.
Hello, sir.
Yes. Click on employee.
Okay. Sorry, the network is unstable. I'm not.
Okay, sorry.
The line is breaking.
Okay, no problem. Move it.
Is it to columns?
Move, yes, move to column.
So
Column is not, why is it not highlighted? Is it network also? Hello?
So it's probably network.
So you know what? Adebayo, have you opened your own? Is it okay now?
Yes, sir. That's what I'm trying to do now, sir.
So you are trying to do, it doesn't take time to open now. We can shift to that because, okay, yes. Click on, move it to, please, Adebayo. Okay, no problem, no problem. Just wait.
left in the fire.
What do you say?
Let's move it to volume for rows.
Please, one after the other. Adebayo, stop, please. Stop for a while. Yeah, now move it to the column.
Okay, sir.
Now go to exact. Click on exact down.
Hello, sir. You said?
Click on exact.
Yes, I've done that.
And there's an exact there also. Click on it instead of asymptotic. Click continue. Now click on statistics. Click on chi-square. Continue. No, okay, now click on cells. Then click on expected. Click on row percentage. Click continue. Click OK. Click OK. Okay.
Hello.
Click OK.
Hello, sir.
Yes, thank you. Oh, yeah,
Hello,
expand the results. The result, yes. Yes.
I've gotten to you have 5,609 days left in your trial. So I'm trying to click on open.
Yes, click on open now. That's about more than 50 years now. Will you be, even by that time, say you will have got another version. So it's telling you that you are having more than 15 years to use it. You know, also.
I should.
You have already gotten it. If you want to go and open, what we are doing, I just open and go and look for where you save all this, the file I sent to you. Go and open it. That's all. It's ready to use. Yeah. Just go and open, go and look for where you save. As you click on open now, it will be taking you to, as if you want to enter your computer. So look for the folder where you save the what I sent to you. No, it's not space. What I sent to you is not where you save space. What you say, what I sent to you as a data file for practice. So go and click on this thing we are doing now.
I didn't get the data file, sir.
How did this person get it? I sent to everybody. Jane, I think James forwarded it. I sent it to everybody.
Yes.
No problem. Later we'll be looking at that one. Because so that we have a lot of issues. Just be following what we are doing now. At least you can go and practice, go and play it and practice. Yes. So that much distraction not coming. Okay. So let's look at the results critically. You can see that the total is 300 at the right corner. If you look at it, it's the same thing as the table which I share with you. Okay. You know what? You can say, okay, let me share my own. The reason I want to share, because I have run it also, I think I put the result here. The result is having now. All these steps now, what you see. So the result you are having with him is what I'm showing. Can you see? Can you see my screen? Can everybody see what I'm showing?
Yes, sir.
Yes. This is the result he has there. This is the result he has there. The same thing. So because this one is on slide, it's bigger. So that's why, so that I can see. And I can control it, because the one is sharing, I cannot control the one that is in control. So now you will see that there are 300 people. If you remember the table is 300 that is there. It's exactly the same thing. But you will see that in the table, I first of all you show 90, 40, 95, 75, and the total 185, 115, and total 130, 170. All this other one, the percentage was not there. The expected, okay. We didn't click on the expected. Okay. I thought okay, I didn't show the expected here. Maybe did I show it on the next one? Okay, let me stop sharing. I want to explain something. Let's use his own. So share your own again. Share that result again, please. Emmanuel, share that result again. Emmanuel.
Sir.
Yes, that's great. It's only that, can you help us zoom it to become bigger? Anyway, people are seeing it. Anyway, hope people are seeing. People are seeing it because we have seen on the laptop. So you will see that 90, 40, 95, 75, the total here 185, 115. Those are the people that total that employ 185, total that are not employed 115, total that are female male 130, male 130, female 170. But you see expected count. These other count we have just first talked about, those are the observed count. The expected count are the one we calculated yesterday. That is the value when non-hypothesis is true. If it is true that the people, the proportion of male that are employed, the proportion of male that are employed is the same as the proportion of female that are employed. We are supposed to have 80.2 male employed and 104.8 female employed. Now, this percentage you are seeing here is along the row because we put the exposure sex along the row and we put the employment along the column. We now say give us percentage along the row. That percentage along the row is along the exposure. That's how you interpret your result. Now, what it's telling us is that out of this 130 male, 69, this 19 over 130, 69.2 are employed. Out of 170 female, 55.9% are employed. So we express in percentage. If you just say 90 male employed, 95 female employed, it will give impression more female are employed. But know that the total number of female is more here. So if you put it as percentage, you actually see in the number more female there. But when you compare with the total of each of them, you can see that the percentage of male employed is 69, is higher than that of female. So we can actually say more female, more male in percentage are employed compared with female. So, and that is what we are testing, that this 69.2 for male and 55.9 for female, the difference is clear. That is observed different. You look at if you minus it, whatever you get, the percentage you get, which is about up to 13% now, is different. If you look at it, that percentage you are seeing is seen by chance or not. Is it by chance or not? So that's what you are testing. Now, I want somebody to quickly do with your phone. Do some calculation because that is a workshop, even though it's virtual. Do some calculation now. The new expected value they give us, please put down 80.2 over 130. And another person put 104.8 for female over 170. Give us the percentage. Please. Some people should do 80.2 over 130. That's it. We are trying to look at the percentage we give us if we use the expected value, because the total is fixed. So if you look at the percentage, 80.2 over 130, and also do 104.8 over 170. Please, people should do it now and give me the result. So give me the result of the one. So Fatima, you want to give me the result?
61.69 for the 80.2 by 130.
61.
0.69.
61.6.
Or approximately 61.7.
Okay. Okay. 61.7%, right?
Yes.
Okay. Who did for the female? This is for me now. Me. Who did for the female now? Who did the other one? Nobody. Unmute yourself and talk. If you don't unmute, I will not hear you. 104.8 over 170. If nobody, Fatima did it for me, Jerry. Because I call this thing, somebody you are supposed to have enough people. I don't need to call somebody. Because that's how you
sir.
104.8 over 170, what is it?
61.64.
Yes, 61.64. Oh, the other one you say is 61.69, right? The other one, what do you call it? 61, repeat the other one, 80.2. Though it is very close. Can you see the value is very close? Hmm?
Yes, sir, it is actually very close.
So it's telling you that both of them, approximately 62% of both of them are employed. So if 62% of male are employed and 2% of female are employed, so that is the expected value. That is the count we expect if no hypothesis were to be true. I don't know if you understand me now. If there's no difference in the proportion of male and female employed, this is the percentage you will get. That's why the count is giving you. That count, it will lead to this percentage for you. So what you have actually looked at now, what we did, the computer did, is to compare this 61 with the normal value. It's not the 61, the observed value you put there. You compare. It's like we're comparing the observed percentage and expected percentage also value, whichever way. So when you compare it, the value when both of them have the same, that is expected value. That is the value when no hypothesis is true. You compare, is there any difference between the observed value and the observed value, all those 90, 40, 95, 97, and the expected value calculated later? If there's, that is what chi-square did. Now, I've already told you also, this expected value, computer give us, you can calculate the row total times column total. Like for this one, I just say 130 for this first cell, for this 19, the expected value will be 130 times 185, which is column total, divided by 300. This one will be 130 times 115 divided by 300. This one will be 117 times 185 divided by 300. This one will be 117 times 115 divided by 300. You get those expected values. Yes, I mean that. So normally when we run it, we don't put it. I put it because you are not going to tabulate it. That's why if you are running it, you don't need to put it. No, we have to check it the other time. We have to say, if we don't want it to give, we don't say it. If you look at the table I put in my slide, I didn't put it. So I think we have explained that. And we have explained also that you can see the percentage, the way you interpret your result now. Is this percentage row you put in the front of the 69.2, 40, 30.8. If you had 69.2 and 30.8, it gives you 100%. The same thing you do for this one, 55.9 plus 44.1, which is the percentage that are not employed. Now, it gives you 100%. So you calculate the percentage along the exposure, along the sex value. If you have put percentage column instead of row, it will give you different value. If you give you different, number one, two things there, if you go and do that, if it will give you different value, if you go and interpret it, wrong interpretation. And it's even wrong, even if you interpret that one, because the percentage that one is giving you is that out of the people that are employed, how many are female? out of people that can you see no employed, how many are female? In fact, that one said will now give you impression that female are employed because you know if you go and put that one out, okay, maybe we should do it again. Please, what's his name? Dr. Akagu, Emmanuel. Please go back to analyze. Just click on analyze from where you are. Click on analyze. You see. You want to go and put column also. You will see what interpretation it will give you. Wrong interpretation. Is it there? Is it there? Is Kaku there? Okay, no problem. Adebayo, have you been?
It's unstable here. I didn't.
Okay,
I'm not been following.
Oh, you have not been following. Okay. Okay, stop sharing. Stop sharing. Just stop sharing. But anyway,
Yes,
it's a video you have to go. Okay, have you read your own? You have your data out now, right? Oh, you said you didn't send to you. Me, I don't like a situation where we have many people in the class. There are not many people that can, because if I can demonstrate my own, but to me, it doesn't make any difference. It's like I'm just talking to the head because it's better one of you know how to read it. Jane, are you not ready? Let me see if I can connect and send to Adebayo since he's ready to work with it. See, he doesn't have this. Let me just check my.
Can I do it?
Oh, you can do it, well. Why should you? Is it the senior one I will be demonstrating for the?
Oh yeah, let them do it today. Let them do it today.
Let them do. Is it the senior one I will
Let
be
them do it today.
how would they even learn self? How would they learn? So let me just quickly 1 minute. Just give me 1 minute because there's no rush in this one because I want you to understand the logic. Is the logic. Once you understand it, you can never forget it. I just it. Yes. Where is that one? Say okay. Let me just in 1 minute. I will send it to Adebayo now. I send it to everybody now. Send. Let me just forward it. Forward it. Modules and data file. Yes. No, it's not this one. Send. Yes, this is it. Jane. Is Jane there? Jane is not there. Don't know why I'm not. Okay, yes. Give Adebayo Diamond. So I've sent it to Jane. Okay, let me maybe Adebayo, I've sent it to you. Maybe I should let me open my own data. Let me just go around because I want to demonstrate that for you. Since nobody is ready. Let me do my own.
I'm having internet connections though.
Who is having internet problem?
Me, Okafor.
Oh, is it phone you are using to connect?
No, I'm using my laptop.
And but your source of internet is your phone.
My phone.
You are using hotspot from your phone. You are using hotspot from your phone. You are not answering me. Okay, I've opened my own. So this is the data set. Let me just go quickly. Can you see? Everybody can see, right? So you go to cross tab, you see descriptive statistic. You go to cross tab.
Yes,
so
sir.
most of anything
that
can present as contingency table. Anything you can present when you are analyzing it is cross tab. So most of the chi-square, there is only a few of them. When we get there, you see the one you don't use cross tab, and they are reason because they are not presented as cross tab contingency table. So anything apart from chi-square, even want to do reliability, CAPAT, other thing, relative risk, odd ratios, since they are presented as contingency table, is under cross tab. So sex, employer. So let him just go straight, okay, so that all those paraphernalia will be there. Go to chi-square and cell. Okay, maybe let me see, put it there. Row and column, you can be rioting somehow, but all the same. Okay, let me share again because sometimes you may, I'm sure you didn't see it. Can you see the result now? Everybody can see the results, right?
Yes, sir.
Yeah. So it's more bulky than the other. Reason be that apart from, if you look at the percentage within, can you say within sex along the row, because it's the sex that is the row we put as the row. Within sex percentage along the row is the other one we did before that show all this percentage of male that are employed and the percentage of female that are employed. But the other one along the column, can you see what is showing up? This one is showing up percentage of employed people that are male and female. Can you see? Can you see the female's own? Which one is higher? The male's female's own is here, 51.4. The male's own is 48.6. Which one is higher?
Female.
Yeah, the male is actually
Female.
the female, because the female is 51.4. Can you see? We didn't employ. The percentage that are employed, the percentage of people that are employed that are female is higher, 51.4. The female zone is 40, male zone is 48.6. If you go and use this type of thing, it will, you can conclude that okay, when we saw the people that are employed, when we counted them, the women are more, and they are saying that they are being marginalized. Can you imagine? That is wrong interpretation, because you are starting with the outcome. You are now going to exposure. No, what you should start with is the exposure. How many in each category? If you start with exposure, because we have more female. So if you look at the percentage of the male that are employed, rather than say the percentage of those that are employed that are male. I don't know. Do you have question concerning that? Is somebody confused? Because that is, many people, they do research, they don't know how to interpret. That's why I don't sometimes. You see somebody's conclude a thought, something you are quoting somebody, you don't know, maybe it's rubbish work they did. You are quoting them. You are quoting, imagine somebody can do this and now go and interpret that the female are more employed. And I say, work done by so and so. Find out that female are even more employed than male. Any question concerning this? So you quote number one. Though if I decide to put the male as the sex as the column and the other one as this, if I run it, I must now use the percentage along the column, just know that I put the percentage along the exposure, within the exposure. Like this one, within the sex is the exposure. Just know that the percentage within the exposure, that's what you are to interpret the outcome. Because you are not, if you now go and put the within the outcome, you are trying to say the outcome is the exposure and the other one is the enrollment, which is does not make sense. I think I've made myself clear in that. Since nobody say anything, because I asked for a question, nobody answered.
Thank you very much, sir.
Yeah.
So no, I actually got the explanation. So the outcome is employed while the exposure is sex.
Exactly.
So is exposure always the independent, or it can be is the exposure socio-demographic?
Exposure. It doesn't have to be socio-demographic, but why you see that she look as if there, because there are potential confounders. There are potential exposures. Yes, it's not always, but potential exposure. If you have given education to some people, health education, well, I'm not talking of level of education. That is an exposure also now. Even as something that is outcome, okay, let's sex and education. Which one, if you are comparing sex and you are looking at association between sex and education, which one is exposure, which one is outcome? Please, I want people to.
Exposure should be sex.
Education is the
Yes,
exposure.
sex is the exposure, education is the outcome. But when you are not comparing education and socioeconomic status, your
Okay.
socioeconomic level, which one is
Okay.
outcome, which one is exposure?
Education will be
Yes,
exposure.
which one has become exposure in that place, and socioeconomic status become outcome. It depends on the relationship between the two subjects we are talking about.
Yeah, okay.
Okay.
Yes, I mean, if you are now say where you live, where you live in the town in Abuja and your socioeconomic status, your resident, place of resident and socioeconomic status, which one is exposure, which one is outcome?
That is hard.
Where you live is the outcome.
Socioeconomic
Socioeconomic is the exposure.
Okay, one after the other.
the exposure.
Okay, maybe you should raise your hand if you want to talk. Who want to talk? Let me share so that I can see.
I can't find raised hand
Yes,
here.
great.
One after the
I
other.
can't raise my hand in this place.
Okay, here today you want to talk. Please, we're gonna stop.
Okay. From what you have said, sir, I believe the where you live is the outcome, and socioeconomic status is the exposure, because
Yes,
it's
most of the
your
time it's like
socioeconomic
that.
status that will determine the kind of place where you are living. Sir?
Place you do, yeah, exactly. But when we are measuring socioeconomic status, though, when we can talk about income, because even residents also is one of the what are four measures. But most of the time when they calculate it, that we just use education, income, and profession. The education, income, profession, and where you live combined. But in that progression, you can see that we're not always the time anyway, all the time. But where your income will determine where you live. Your income will determine. But in Nigeria, hardly your profession even determine where you live now, where the money you earn. Because it do pass, even people that are doing some party, they earn more. Everything is scatter. So you cannot bet. That is the logic. Then somebody can look at it along the way also. Where you stay over time may determine what you become. Are you understanding now? If somebody, it may not be the other way around. If somebody stay long in the village and somebody stay long in the city where is exposed, at the end of the day, the person that is more exposed may be able to become more renowned or achieve more in terms of the society value than the person. So you can look at it from, it depends on the setting, but most of the time, your income will determine where you live in a particular town, like in a particular town now. Your income depends. The people that live, people that even if they have house in this, or when they have money, they go and buy a house in Asokoro and move down to Asokoro because that's why they begin to see benefit. If you do, yes, Jabi, if Jabi, because when you do, okay, let's continue, please, so that will not disturb our listening. Now, I think you have got it. Yes.
Sorry, I'm missing out. Oh, I'm missing out.
Who is missing out?
It's Jane. Oh,
he's calling you. You were not there. That's why I see you show your face. Because you are not there. You left that. I was calling you. You didn't answer. That's why you left the computer to go and take tea. Okay, what is the problem?
No, not at all. But I told you, you know that I'm on the field now.
Yes. Go on.
I didn't follow anything you did. The SPSS you ran on using chi-square and that first exercise, I did not follow anything. I beg. I don't want to let out.
The issue is that you can easily watch it because we are videoing it, so you can easily watch it. So
no, sir. Video. If I watch a video and I don't understand a particular thing, I can't ask the video any question now. Just, I beg, even if it's 2 minutes.
I want to run the explanation. It's not the step, right? It's the explanation as you explain the result again, right?
The explanation is not enough, sir. Go help me go back and let's run it.
You know how I run it.
Hello, Jane. You are taking us backwards.
I beg. You people should please video. I beg.
Because the person that is talking now is the guru in what we are doing. So what you want to get here is maybe different from others. So we have to marry, but we should not rob Peter to paper. So we should balance. Yes, I mean, that's why I don't want. We are wasting a lot of time installing SPSS. So no problem. Graphically. So let's.
Okay, I was about to do that 4 p.m. Okay.
What do you say? Don't worry. So let's just continue. Let me just quickly explain within short time. Now move. What I did there is that on this table, you can see the observed value, the value that we showed yesterday, the real value you observed in your study, which is 90, 40, 95, 75. The percentage you are seeing here, there are within sex, within employment, is the direction of the percentage that show where they are coming from. Within sex, it's telling you that you say, among male, how many employed, how many are not employed? The percentage of employed and percentage of not employed. Among female, the percentage of employed and percentage of not employed. But if it is within, can you see now you start with the exposure because with sex, within sex, that is among the two category or the different category of the exposure, what is the proportion that have the outcome? Is it clear now? But the one that is the row because we put, well, it can be color. If we let's say we have put the sex as our color, but we put our distance as row. When I was clicking, I said, give me row percentage, give me color percentage. So the one within, you make it easy, either row or color. It will tell you within sex, within, if you put the 2 percentages there, within, you know, sex is your exposure. So it will tell you within sex, this is the percentage that are employed or not employed. But the other one that is along the column is telling you among the employed, how many are male, how many are female. Among the unemployed, how many are male, how many are female. Do you get that one different right now? Let's start with that. Jay, you get it different, I just say right now. Did you get that different right?
Yeah.
Yes, you get that different right. Yes. Now, what I'm now saying now, it is wrong for you to use the percentage along the outcome. You use the one that is within or along the exposure. And that is why the row, the first percentage, the one within the sex is the one you use. So what is telling us if you use that one within the sex, 90 out of 130 is 69.2. 69.2% of male are employed. Then if you come to the sex, it is 55.9% of the female. That is, that 95 out of 170 is 55.9%. It shows that male are more employed than female. But if you take a wrong direction and now start using the within the outcome, within employment, the one, that second one, it will tell you that within, that is out of the employed, out of the employed people, 48.6% are male and 51.4% are female. So Jane, from that sentence now, who is more employed? Is it within the employed people, or the people that are employed? You discover that 48%, 48.6 are male and 51.4 are female. Who is more employed? Can you all give me an answer? Jane. It's not there again. Can you see?
I'm here trying to catch up with what you are saying.
I asked you a question. I said, if I say that among the people that are employed, 48% are, 48.6 are male, 51.4 are female. Who is more employed among male and female?
The females now.
Okay, that is the wrong interpretation people will give, because we are saying among the people that are employed, we are using employment, which is the outcome, as our base to calculate the percentage of male and female. Is wrong, because do you know how many people that are female that in that category of female? You have not considered that. You know how many that are male? So in this case, female are more than male. That particular 95, though is more than 90 of male. 95 of male are employed. 95 of female are employed out of 170. 90 of male are employed out of 130. If you do that, you will know that more male are employed, because when you now put the percentage, it's the one that give us within sex, it's the one that give us 69 for male and 55.9 for female. So in this result, more male are employed when it comes to the percentage, not the absolute number. Does it make sense? Is it clear now? Please answer. Yeah. So that's what I said. That was what I said. There's no other thing I said in that place. Yes?
No, you said something about the absolute value.
What I mean by absolute value are 187 people are in employment. They say there is work. 187 people are working. In the group, 185 people are working. Out of the 185, 95 are female, 90 are male. That is the absolute value now. If you look at the absolute value, you see that more female are in that work, got the work more than male. That is absolute value. That is wrong interpretation, because that 95 female out of 170 of them, and that 19 male out of 130 of them. If you look at it, you now know that more male are employed. Does it make sense?
Yes, sir.
So you need to understand this statistic to be able to interpret results. I think that's what we have done now. So we move forward. Then let's look at I've explained all these things. If you remember our degree of freedom, I don't think we should have issue with that. It's 2 by 2 table. The degree of freedom is 1. Number of rows is 2. 2 minus 1 is 1. Number of columns is 2. 2 minus 1. 1 times 1 1. So the degree of freedom is 1. Can you see table C? The chi-square we calculated is the same value we have here. Continuity correction is the same. Can you see? Likelihood ratio, can you see? Is the one that is a little bit higher than the other one. And that's what we calculated. You will now see log linear analysis and okay, Fisher is that. Now, we talked about weight correction yesterday, and then we say something, we are not repeating it again. Now, I want to talk further about that Fisher, because we didn't talk much about it, but I told you, Fisher exact, instead of calculating chi-square, you calculate chi-square, you look at the p-value that corresponds with it. The Fisher exact is p-value straight, is probability straight. What they calculate is probability straight. Now, it's not even, we don't even know, bother yourself on how they calculate it. But what you bother, what I want you to know is that, why should I use it? We already talked about the condition for using yield. 3 different conditions conflicting. This is when you have expected value. Expected value. Now we should know that the expected value is different from observed value. So what you have in your table usually showing your result is observed value. The expected value, you know the way to calculate it. But if you are running a computer can calculate for you. Like what we did here. We have the expected value here. Now, you will see that for the yield correction, they say if the expected value is less than 10, it's obsessed. Some people say if it's less than 5. Some people say that any 2 by 2 you use, that is their condition. Some people say they should not even use. But what is the condition that make people to prefer to now use Fisher exact value to chi-square? Now, the chi-square, if you remember in the slide, one of our slides, I don't want to go there so that you can save time. Yesterday, I said that you need higher, sample for that contingency table. That is, if you have 4 cells, you should have enough to fill the spaces, so that, though it doesn't really mean that you can even have 0 value in a cell, the expected value can be big. But most of the time, whenever some value is scanty, the expected value will go down. You get it now? So that is why if the sample size needs to be big enough for the number of cells. If you have a sample size of something like this one now, 300, 2 by 2 tables, okay, you see that the way you feel it very well. But if it is you are trying to compare geopolitical zone and the socio-economic status, socio-economic status here, or even education, say the level of education, geopolitical zone. Level of education, you have 4, no formal, primary, secondary, tertiary, geopolitical zone. There are 6 of them in Nigeria here. When you multiply 6 by 4, it gives you 24 cells. With this 300, you're going to see some cell will be scanty. You'll be having problem. So the man said, if the expected value, if you look at one of the conditions also there is that for this chi-square, apart from the 5, you need higher sample size for the contingency table to fill up. You now say that there must not be expected value less than 5 in more than 20% of the set. Let me go there because sometimes because I'm sharing, I'm going to share the slide with you. So let me just make clear so that you know that it's there. What I'm just saying, I'm not even seeing that. Let me just go because I showed you yesterday. So we just wrote through quickly. I will show you. So you now say that the expected value should be at least 5 in up to 80% of the cell. It's one of the conditions. And I say we see explain it further. Look at it. Look at this number for relatively large sample size. Expected frequency for each cell are at least 1. That is, there should not be any cell at all that has expected frequency less than 1. The expected frequency is not the frequency you are seeing there. It's not the observed. It's not the one you tabulate. It's the expected. You know how to calculate it. Row total times column total divided by grand total. Is the value you expect. If not, I put it, there's no difference. Now, it must not be less than 1 in any cell. That is, there should be at least 1. You can see. The second one, the expected frequency should be at least 5 for the majority, 80% of the cell. Can you see? Majority. That shows that you must have at least 80% of the cell have expected value. 5 at least. That shows that the expected value should not be less than 5 in more than 20. That is, you can still take expected value less than 5 in 20%. Because we'll remove 80, 20%. But the expected value should not be less than 5 in more than 20% of the cell. I think it's very clear now. Now, if you go back, let's just, it's quite interesting, but okay. Yes, this is the result. Now, if you come back here, so when you look at it critically, you will see that this cell now, this is our 2x2 table. One cell is 25%. If the expected value is less than 5 in any one cell in 2x2 table, the chi-square is not valid. Can you see? It's not valid. That is, the result is giving you, you cannot depend on it. But if it is the cells, there are 6 cells. You know, you cannot have 5 cells because the cell is usually in multiple of 2. 6 cells. 1 cell out of 6, the percentage is 16 point. You know, half of is 16.7, something like that. Yes, 16.7 yes, percent. So 1 cell, if expected value is less than 1 in 1 cell out of 6 cells, the chi-square is still valid because that 1 cell is not up to 20%. It's not more than 20%. But if it is less than 5 in 2 out of 6, 2 out of 6 now is 33.3%. Can you see? So if it is 8 cells, one of the cell is 12.5%. Expected value less than 5 in 1 is still valid. But if it is 2, that will be 25%. It will not be. So when you have maybe 10 cells, maybe even 2 cells, you can still be less than 5 is still valid. So many things. Sometimes the examiner, when they if they don't, people even maybe some people may not understand. When they just see 1, in fact, many people make when they just see 1 cell that is scanty, You say this value is less than 5. In fact, some people can say you have to come back. But the issue is not even the value you are looking at, is the expected value. Not only the expected value like that. If the number of cells is much and it's just only few, it's not up to 20%, still okay. So the expected value has to do with it. But if for it to be less than 1 in any cell, it's not valid. In any cell, it doesn't matter whether it's 1% or 2%. Once it's less than 1 in any cell, it's not valid. Those are the two conditions. And SPSS says the people that do it also, the program also, they have higher statisticians to advise them. And they are very intelligent also. Look at what they did. Under this table, look at it, they will tell you, in there they say 0 cell, 0% have expected value less than 5. It's because it's 0 here. They will cut the number of cells and now put the percentage of that number of cells out of the total number. Here now say no cell, that's 0 cell. Of course, it will be 0% have expected value less than 5. So if they give you, you'll be able to know the percentage of cells that have expected value less than 5. Once it's more than 20, you know that it's not valid. Then the second condition, you now say the minimum expected value is this. It will now quote the minimum expected value for you. Of course, by the time you get the minimum expected value, you will be able to know if there's one, if it's less than 1. Is it logical now? Even the SPSS people, they are put it there. You see it. Somebody want to ask question? Somebody want to ask question? Somebody want to ask question?
I have a question.
Okay.
I have a question. It's quite interesting. So you're telling me that all those times when we're talking about officials, that is the expected, not even the observed.
It's not the observed, it's the expected value. And it's not the observed you are looking at there. Sometimes you can even see some cells may have 0. The expected value may not. So what you allow you, if the expected value is going to be small, is the total along the row or column. When you begin to see total, it's very small. But when you multiply by the total on the other side, it is going to be very small. By the time you divide by it will be small. So it's not the, sometimes you can even have Dr. Ogubure if you want to talk. Somebody is talking, right?
Oh, sorry. Okay.
So that's just it. So now I think if there's no question, I think we can move forward. Please ask your question. There's no question that is stupid though. So ask your question. Okay, so no, it's not here. I'm going to. Okay.
Please, sir, and there was something else you were explaining when you were talking about that binomial, where you talked about that, you said half, the 0.5.
0.05.
I understood the whole thing. I understood the whole thing.
No, we are talking of, don't take us back to that Yates correction. You know, I said, when I was here yesterday, I think it was Okafor. I was asking question on why is he minus something. And I said, okay, it's going to be, I will be struggling explaining it. So let me bring the pictorial. So that's why I brought that in. We are ready to look at why the person, sometimes some people, some of those things, or the detail that some statisticians go into, they are not so important much, but there are some detail that may be academic. At that level, even the expert, they will be disagreeing on some issue. That's what happened about the Yates correction. When it's the same Bonferroni correction, the same thing. When we get to ANOVA, Bonferroni correction, there are many people criticize Bonferroni for overcorrection. Okay, let me. I still want to.
I have a question.
Okay, sir.
Can you hear me? Can you hear me?
Yes, sir. Yes, sir.
So, when you cross-tabulate and you have a contingency table, and let's say a particular cell or 1 or 2 are less than 5, what you are telling us now is that you cannot concentrate on Fisher exact until you finish analyzing it, and you now look at it again.
No, what do you mean by that?
Prior to this time, what I had in mind is that you look at your contingency table. If, let's say, a cell is, let's say, having a value of 2, what I was told was that for that particular one, they're going to use Fisher exact to analyze it. But from what you have said now, you have to finish first and now look at your statistics,
So
expected
it's not a
value.
matter of finish
and
spread. How did you get your table there? Even from the table you can calculate. Now the we already said that.
No, I don't calculate. I
You
always
can use
use
hand to
I
calculate.
always use SPSS to analyze. I always analyze.
Okay. If you analyze, if you look at it, when you analyze, you can, if you want to know the expected value without calculating, you go and click on the option under the cell. Is it by default? Look at it now. By default.
No, I know.
So even the examiner says, sir, you bring the table. The examiner will calculate the row total, column total, and divide it with his phone. He will tell, he will know. You can even with hand, you can get your expected value for each of the cell. You'll be able to know if any is less than 5 and how many of them have expected value less than 5. Like for 2 by 2 contingency, you know that if you have one cell that is less than 5, one cell is 25% of the whole because there are 4 cells. 1 out of 4 is 25%. Then, for 4 6 cells, it takes 2 for you to have more than 20%. For 8 cells, it takes 2 for you to have more than 20%. For 10 cells, it will take 3 cells for you to have more than 20%. You see? So if you have 6 cells, if one has a certain value less than 5, there's no big deal.
You can just go ahead and use Fisher Excel.
Yeah, you use the
chi-square. Because that's what I've been doing.
Okay.
Oh, you use chi-square?
If you have 6 cells and it's only one that has a certain value less than 5.
Okay, let's say 1 is 2. 1 is 2. 1 has a value of 2. Has a value of 2.
I'm not getting what I say. It's not the value of 2 that matter. You have to calculate the expected value for that cell. Okay, let me just, don't worry, I will share, let me just open a table, live table in the Word document. Let me just open a live table in the Word document, just a table, you get what I'm saying. So just a table, you get. Because just all these things, they are not something that you fabricate from any place. Okay, let me just, just 1 minute. I'm through. Result. So because some of these, okay. So somebody you know asking, where did I get this table from? But just for demonstration. SMU. Yes. Look at the table like this. Can we see? Can we all see?
Yes.
Yes, sir. Yes.
Yes. So you can see that. Look at. Okay, I'm looking for one that has extremely smaller value. Can I see any table that extremely small value here? Let's look at this table. Let's look at marital status. So in this place now, this marital status 1, 2, 3, 4, 5, 6 row, 2 column. Can you see? We are having 12 cells. I'm sure it will take maybe 3 or 4 cells before you can have more than 20%. You can calculate it. What 1, 2 out of 12 is not up to 20%. It may take 3. That will be more than 20%. So now, what we mean by is not because I see 1 and I say, oh, this one. If I want to calculate expected value for this cell, say the last cell to the left, that have 1, to the right rather, that have 1. The row, you have to know what is the. If you look at it, the total along the column, around the row is 1 because it's 0 plus 1, it will give you 1. The total is very small. Then the column total is the total for that column 486. You can now say 1 times 486 divided by grand total. That will be 486 2 times. Of course, with that, the expected value is very small, less than 5, if not less than 1 cell. you will know that these two cells, even including all these cells, can you see now? The only thing we can try to calculate how many, maybe all these 6 up to 4, half of the cell, all of them we have expected value less than 5. Yes, I'm now. This 50% of the cell. If you look at it now, we have the chi-square, this column is chi-square, this is degree of freedom, and this is the P for chi-square. We now put Fisher exact P. We now say that Fisher exact P is this like a cross. It's saying that it's Fisher exact P that is using, because more than 20% of the cells have expected value less than 5. In fact, so sometimes if you calculate, you may even see one that have less than, maybe this one have less than 1. In that case, even when you even see one less than 1. If you look at this one now, let's go to, I'm looking for extreme, something that has extreme value, but is still valid. Because you can still see, you can even have 0 in one cell. Yes, look at this one now. There is 0 in one cell here. Can you see how long to class meaning? There is 0. But the total for that level is 94. 94 versus 0 is 94. If you multiply 94, please, somebody should. Hugo is your work. 486, what is the total? 486 times 2. What is the total for the video?
Okay,
486 times 2. Each of them is 486 now, right? Is that not so? So
Okay,
the total is,
486 times 2 size 972. Okay, yes, my work. Yes, 972. Sorry, I just realized.
Okay, 972. What is it? Yes,
I just realized. Yeah,
972. Yes.
Okay.
Now, if you want to calculate the expected value, now say 94, because for this cell now, the row total is 94 when we add 0 to 94. Multiplied by 486, which is total for the column. Somebody should do it. Divide by 972. So if you say 94 multiplied by 486 divided by 972, it gives us 47. Can you see? The 0, the observed value is 0, but the expected value is 47. So that is why we didn't put Fisher exact. We still use chi-square.
Okay.
Can you see now? So it's not the absolute value. But once of you they just see 0. Yeah. Somebody say, even when I was doing exam, only I even see some even say have 0, and you are still having chi-square for them. I think. And I say, is this one, is it normal? I just say, sir, you know you are an examiner. No, sometimes the examiner, even if they are stupid, you won't tell them they are stupid. You just have to bow down and pass. And I say, thank you, sir, for your observation. I will now explain. The other person that has sense now will shake his head. But you know, at the end of the day, if you know what you are doing with humility, you can even make an examiner look stupid. But you won't let him, you won't do in your action. You should be respectful. Sorry, ma. Thank you, ma, for your observation. This you now explain. At least if the other person is not a sadist, you will understand that. So in defense, it's not, you don't allow anybody to wash you down, because some people are ignorant. They just, and you have done good work, and they bring you down and they finish you. Somebody has failed in O&G before. Because he did cross-sectional study and used odd ratio. The examiner just said, oh, it's not case control. You cannot use odd ratio. You come back for it.
So I thought you used odd ratio.
He failed. It's so painful to me, because why should the person that did the right thing fail? So even to myself, even if it's a mistake, that was not enough for the person to fail. It's something you can, okay, why did you use this one? This is the wrong, you will have done this one. Well, he did the right thing, but he failed. The examiner they didn't go further again. No more exam. No. Odd ratio. So those are the issues we'll be trashing out. I think we can, let me just stop there. I think we understand the logic.
Yes, sir, I have a question.
Okay, go on.
I have a question, sir.
Yes. Yeah, go on.
It is concerning this degree of freedom.
Okay.
And you know, I believe these tables now, I can see is a 2 by like this satisfaction with monthly income now. We have two categories, maybe public or private.
Yes.
How do you cross tab to get that degree of freedom that is 4?
As you can see,
Because there was a time I did my own course and I was getting like a 4 by 3. I was getting 9 as the degree of freedom. It has 4 range, and I was wondering why.
How many row? How many column? Okay, no problem. The issue here.
It was 4 rows.
How many column?
4 rows and 2 columns. 2 columns.
That's degree of freedom is 6. It's 3. Degree of freedom is 3 because 4 minus 1 is 3.
Okay, I think it's 5. I remember it's 5 because they wrote 4 there, so it's 4 row minus 1. But in the cross tab that I did, I was getting 9 as the degree of freedom.
No,
I was wondering why.
You know, sometimes also I don't know. Maybe if somebody, I don't know how you did your cross tab, because sometimes somebody might have collapsed. Because if you do your cross tab, the computer cannot give you.
Actually, I was doing the cross tab for age group. I was comparing 2 age groups.
The computer cannot even give you the wrong unless you miscalculate it. The issue is that look at it. You say which is. There are 2 columns here now. The column for maybe either private, the column for public. Then, like, which one are you talking about? Which one should I talking? Which one here is the one we are showing? Which one will I talk about here?
Anyone, just give an example of. You can go to the age, use the age so that I understand.
Because your
age.
Okay, look, this is age now. Now,
use age. Okay, let's see.
4 categories. 4 categories of age here. Can you see now? Then you have the degree of freedom is 3 because you see that look at it, it's 3 because there are 4 rows. 4 minus 1 is 3. There are 2 columns. Public and private, 2 columns. That's all. So if I'm running it with computer now, I will just use I will use age as the row. I will now use the age group as my row. I will now use the column as this column, the group variable, because there's a group variable that differentiate them to public and private. I will now use it as a column. So the percentage here is different too, because the way I did the percentage here now, if we first of all draw the percentage and the frequency before we now do, when we are calculating chi-square for this one now, we don't consider, I've already put my percentage. What I'm looking for is the chi-square. Do you get the picture now? Because if I want to run it with chi-square and do this table like this, because this is a frequency, these are frequency table. Since it's a comparative study, you are putting side by side. So what I do, I split the file. When you split it, you run them separately. You run them with the percent. So the percentage is along the column. Yes, because this 160 is over 483, 86 to give you 32.9. It's when you are cross-tabulating, when you get to the table of correlation that the thing will be, the percentage will be along the exposure. You get the picture now. This percentage now is along the row. Can you see it? So if you have 32 to 0.9 to 55 points, it will not give you 100%. It is when you have it vertically that give you 100% because this is the frequency. But when you get to cross tabulation in this work now, that's where you see the percentage along the row for good interpretation. Look at this one now. No, I'm seeing with frequency. Okay, I think I've reached. Okay, look at this. Look at the same age now. So we did the cross tabulation here now. We now say high, moderate, low. These are 3 categories. It doesn't really matter. Now, you will see among the people that have less than 20 years old, how many have high? How many have moderate and low? The percentage of high, moderate, and low add up to 100. Yes, and the percentage is along the row. So it gives me 8.8% of people less than 20 have high. I will now compare with the 6.8. You can see as if there's a trend, but if you do chi-square for trend now, it may be, well, it will not be significant. You know the reason? If chi-square, the Pearson chi-square is not significant, the chi-square for trend can never be significant. Yes, now. So the Pearson chi-square can be significant, the trend may not be significant. They cannot be the other way. So both of them may not be significant. Like this one now that the Pearson chi-square is not significant, but the trend also is actually done for two outcomes. We cannot do trend here now. But the one that has maybe good or poor, there is not three category of outcome. Where is the one that has to here? Look at high and low now. Example of high and low here as the outcome. Yeah. And high and moderate and low also are ordinal scale. So if I want to calculate chi-square for trend, that is along because the exposure is ordinal, along this exposure that high and low, the copy strategy does it increase or decrease along, the trend will come in. But even the trend, if the Pearson chi-square is not significant, the chi-square for trend will not be significant. So what it means that if you see there's a significant difference, we want to see that is the difference increasing or decreasing. We'll talk about that, please. We have not even reached chi-square for trend. Let's just close that and finish up with what we're saying. I think you will better understand what we have just said now. So the logic, I think we are now have the reason, you can understand the reason for using Pearson Fisher extension. Here now, Fisher exact is not useful here because the condition for chi-square is okay. Now Pearson, this is your chi-square you quote. I like using this thing so that this is your chi-square, degree of freedom, the two-tail, you are two-sided. Two-sided. You are looking for two-sided. So it's not one. If you are looking for one tail, you look for one, but it's two-sided. So let's now look at the other thing I want to explain here. Look at linear by linear. That is what is the chi-square for trend that SPSS called linear by linear. It's chi-square for trend. But you know, computer is garbage in, garbage out. So it's process. Chi-square for trend is not needed. You cannot even calculate it for 2 by 2 table. The reason is not needed because number one, the condition for using chi-square for trend is that the outcome must be 2 categories. This outcome is 2 categories, no problem. But the exposure must be ordinal. Exposure must be ordinal. If let's say our exposure now, if we run the chi-square, okay, we are still going to do that for trend. We run the chi-square, we look at socioeconomy, look at level of education and employment. Employment, not employed is 2. But level of education is ordinal. Then we calculate chi-square for trend. You cannot have trend if you don't have more than 1 category, more than 2 categories. And it has to be ordinal. You can have more than 2 categories, not ordinal, like marital status. It's not ordinal case. So even if it is more than 2, you cannot be talking of trend. I think we are done with this. I think.
No, I have a question.
Okay, sir. So that we'll move forward.
I have a question there.
On, sir,
I just need clarification. This exact significant, 2 side, exact significant, 1 side. The whole of that statistic is it only for Fisher exact? Because it's the same value all through.
Yeah, actually, let me
the
tell
same
you.
Value all through.
Yes, you know, it can be. Yeah, it can be the same. Sometimes it will be the same. Sometimes it may not be the same. Because sometimes if it's very close, it can be the same. Sometimes, no, if you look at, okay, likelihood ratio give the same, likelihood ratio give the same thing as Fisher exact. It just happened to be like that. It's not that I always like that. Okay, it's for the exact, yes. You see? Okay. The exact, what we already said that the exact, okay, I understand what you are asking. Yes. The exact does not depend on the, if you look at the exact, does not have statistics. And you see, it doesn't have this statistic as far. This value, these are value of statistic. It just have p-value. It's repeating the same thing because whichever is the same data. It's just giving, you know, program the way computer, there will be repetition. You know, that was the case we saw with ANOVA the other time. You know, trying to compare 3 categories. So you have to hold one. Category A compare with B and C, category B, A and C, category C, B and A. There will be repetition. That's what has happened. So that is calculated, yes. So now let's move forward. There's no question. So let's do the next thing, which is we are trash out the person and all this. Let's move to the next stage. These are even in the slide. All this I screenshot the step you go through. If you want to go and repeat it, let's look at chi-square for trend now. This one will not waste time. Two categorical variables, two or more categories, group for each variable, independent of observation. There is no relationship between the subject and each group. It just tries to tell you that it's two independent groups. It's not pair observation. Categorical variables are not pair in any way. Okay, that's what I just said. Last sample size is expected also, just like, wait, you. See, am I sure? I mean, oh my God. I thought
I was wondering.
I was wondering. I was wondering. I see that because it's a statement that I contradict what I said before. So, is this slide when you This is for assessing whether a binary variable varies linearly through the level of an ordinary variable. I think that one summarizes what I said. The binary variable is the outcome variable. Does it vary linearly? Linearly means that does it increase or decrease as you are moving along the exposure variable that is ordinary? That's just what it is. Now, no hypothesis is that the value of the outcome variable is the same for all the categories of the ordinary variable. That is, look at, for example, now, example we have here, okay, this one just the formula to demonstrate it. And sometimes you may be lost in the formula. I just put it there. If maybe you have the slide, go and look at it, because sometimes you can confuse people. But if you let people see real life data, you can make reference back to the formula. I usually prefer that. The people table will show the employment status among the people. It's the same data file we are using. People of different level of education. Can you say that employment varies linearly along the level of education? You can see the same exposed, non-exposed, employed, non-employed. But we now look along the no formal education, primary, secondary, tertiary. If you look at the percentages now, percentage are employed, it is very, you can see 33.3 of no formal employed, primary 41%, secondary 64, 86.7 for tertiary. Can you see the employment rate increases? Look at the tabulation is along the horizontal. That is, what is saying that among the normal, no formal education, there are 15 of them. 5, that is 33.3 are employed rather. Among the primary education people, there are 85 of them. 35, which is 41. So if you 41.2 are employed, then 58.8 are not employed. If you add the two together, it will be 100%. So 80%, which is 64% of out of 25, 125 are employed. Then 65 over 75, that is 86.7%. So the percentage of people that are employed increases as education increases. You want to see, is this statistically significant? It's not all the way that you see it linearly like that. You can even see when the thing increases like this, it can break in the middle. But it doesn't mean that it doesn't increase, just little break. If you put it to test, it may be saying that education, the employment increase for education. For the fact that maybe you reach tertiary, the percentage becomes small, doesn't mean that there is no linear something until you put it to test. Now, is one like a complex calculation like this, which you don't even need to know the basis, but I put it there. But if you run it, if you calculate it with the hand, we follow this step, it gives you 39.186. And the degree of freedom is usually 1. Even though, irrespective of the number of categories, for trend, the degree of freedom is 1. So If the degree of freedom is a chi-square that with degree of freedom is 139, even if the degree of freedom is even 6 or 10 self, it's still higher. So you see, that shows that there's a trend. But it's better understood. Let's run it. Can somebody, David, can you share your own now? Let's run it. David, I sent it to you. Did you download it? David is no more there. People see that they are tired. They are. David is not around. Okay, Jane, can you share your own? Jane. Jane.
Yeah,
Right here. Can you share your own?
Yes, I'm here.
Share your own. Share your socioeconomic status. And let's run that trend. Or you are not there to share.
I'm here. Yeah.
Share your own. Did you open your SPSS?
My SPSS is open. I'm trying to download the.
Download it from the internet.
No, I already downloaded.
Sure, if you know where you save it, just go and. In fact, with version 25, you may not even open SPSS. Just, I don't know why the other one was not doing that. Just go to that folder, double click on it. It will open. It will open SPSS and open it. That's
okay. I'm sharing now.
Okay, that's great. Okay.
Okay, can you see my screen?
Yes, you can see. So go to analyze. It's the same procedure, just go to descriptive statistics. Cross tab. Move employment as the column and move education as the row. Yes, education is the exposure. So, well, I wouldn't know if you just go and click on the maybe, because I wouldn't know if you didn't click. Okay, go and click chi-square. That's all you need. You can do all those paraphernalia you did for the other one. You can do. Hello?
So this statistics does not.
Hello, I'm in the workshop. What do you say? Just click.
I was saying that, I noticed that she clicked on the statistics. Okay.
Yeah, you need to click on the statistics and click on chi-square, that's all.
I should click on chi-square. And what I'm saying is that chi-square automatically generates a chi-square for trend for you.
Exactly. Once you click chi-square, because that's why it gives you chi-square. It will give you, yes, correct, if it's 2 by 2 table, it will give you likelihood ratio chi-square. It gives you chi-square for trend. But if you didn't say yes, I mean, just do that. Just what we even need, just click on the chi-square, then let's go. Leave for those percentage. If you put also is the same percentage, the same thing apply.
Okay.
The same thing better, just the same thing just apply the way you do the other one. But if you look at it, it calculates together with those one. Click OK.
Can you click on exact so we see what will come out from there?
And you can click on exact, do all those window dressing, and let's see.
Okay, let's see.
Should I click on OK now?
Okay, yes. Hello, Dr. Ero, I'm in a workshop. Hello? Yes, I'm in a workshop. I'm in the workshop. We'll talk later. Yeah, I'm doing on the Zoom, the statistics workshop. Okay, thank you. Yes. Okay, go and share the, okay. No, the way your computer behaves, go stop sharing and share again and share the result. Because if you don't want, stop sharing, then go and share the result immediately. Check the result. Yes, great. Scroll down. Scroll down, scroll down. Scroll down. What's happening?
Sorry, it's a different screen showing again. Sorry.
Okay. You know, it's on the same screen. Okay, maybe I should just run it here because I have the data. So let me just, see my slide. I was scroll down. That is the same thing you show. It's the result you show. I can see it. Yes. So can we see it now? You will see. Can you see the linear by linear? Linear by linear association, can you see 39.185? That is the result we get in that place. And the degree of freedom, can you see for chi-square, Pearson chi-square, likelihood ratio, it will tell you the degree of freedom is 3 for the same data, which is actually 3. But for the trend, the degree of freedom for trend is always 1. Can you see? 1. And you look at the chi-square, 39.1 something.
Why, sir?
Yeah.
Why is it 1?
Yes, the logic behind it. It's not based on, it's a linear trend. It's not based on contingency, the contingency table, whether the row or whatever. It's the linear. So if you go with, I share the slide with you, just go through. I think I'll share it even with those of you that attended the other time. You see it there. Yeah. You see. Look at the logic behind the calculator. I don't want to be explaining because number one, you don't even need it. But anybody that needs it is there. That's why I calculated it there. They just know. So it comes out when you are actually doing any chi-square that has the thing is 2. I mean the column, the column is 2, the row are plenty. You look at the picture now. A row are more than, so it comes out even when it's 2 by 2 anyway. So but you know when to use it. So because if you are doing your exposure is ethnicity or marital status, you know you are not doing trend even if it's more than 2 categories. Okay, I think we stop sharing. Let me go and share my slide. Let's move forward. Any question concerning chi-square for trend? Any question?
You explain it in this slide, Abby.
Look at it now. You look at it. Look at it. Computing it. Look at it. Look at it. Yeah, it's been there. So.
Okay, sorry, I have a question.
No, stop. Let me see.
Don't worry. Look at the results. Here. Oh, yours your question.
How do you determine that there's a trend in the data you have?
Is it how do you determine there's a trend that should be trend, or you want to test which one you should look for trend for?
Okay, because I'm looking at this data set now. You are saying there's trend, and you are saying we'll test.
Okay. Can you see your output? You see what I'm projecting? That's the same output you brought out. That's why I put it on the slide. Can you see? You have 5 here. Look at how many are employed among people without without education, formal education. How many are employed?
5 of them, 33.3%.
Out of 15, which is 33.3%. 5 out of 15, 33.3%. For primary education, 35 out of 85, 41.2%. 41.2% is not higher than 33.3. Then secondary education, you see how 8 out of 125, 80 are employed, which is 64%. Is not higher than 41%. Then tertiary education, out of 75, 65 are employed, which is 86.7. Is not higher than 6. So you see the percentage that are employed is going down. The percentage that are not employed are going, in the percentage that are employed as you move along the education is going up. The percentage of people that are not employed is going down as you move along the education. Whichever way. If the percentage of employed are going down, the unemployed will be going up. So, and vice versa.
Okay, it's fine. I understand your.
And yes, what do you say?
I understand your definition of trend now. I understand trend to be, something you are measuring over a period of time, but it's like it's being used in a different context here, so it's fine.
It's not a different context. The trend is used in different contexts. Yes, Amina. So even you, if something is happening in your organization, you see that as somebody going higher, some people going higher in their organization, they're becoming more difficult. It's a trend. Yes, you can leave it, you can see, oh, it's a trend. Oh, they say something, sometimes even in the English, they say the trend run is family. But this one just know that trend means something increasing or decreasing based on something. What you are talking about, you are talking of time. You are talking of
a particular thing decreasing or increasing,
Yeah, it's not necessarily me over time. Over time is trend. Along, you are using time as the exposure in that sense.
Yes.
As time increases, but you understand now. Also, it's not only time that increase. Also, you get the picture now. Or it's not only time that increase. As something increase or decrease, also an attribute that can increase or decrease. Only variable that you can order like that. Okay, this one also along the age group also you can do trend, because when you categorize age, the age category is the ordinary variable. I think we continue. Is there no more question on that, right? Now, let's quickly look at goodness of fit before we close, because we delayed one today because we are supposed to finish with chi-square today, so that tomorrow.
I don't understand something though, and it's affecting me.
Who is that? Who is talking?
It's yesterday that is talking.
Okay,
I was still thinking about that chart that you show us, Dr. Gonaya's table about public and private. For people, because I don't understand, I'm trying to an analysis and I don't understand. For public, they have their own age group. And for private, they have their own age group. How do you now compare? How do you cross-tab?
Okay.
I think it's chi-square that you use to cross-tabulation.
Yes, now. How do you cross? Forget about chi-square. It's not chi-square we use to cross-tab. We cross-tab is bring the chi-square.
What do you use?
What do you use as well?
How do you compare both the public and the private? The age group of people in that category.
Listen to me. Is it the logic or how I use computer to do it? Which one?
Not computer.
The logic.
SPSS.
And the SPSS. How did I use the SPSS to do it?
Yes. Yes.
That's what I just say. Okay, don't worry. Okay, I will read something that has two groups for you now. There is no, because it's our own data. I don't want to be, if I have to, I don't want to be running, I don't want to run that data. But I will read a particular data here now that has two groups. I will show you how that type of thing is being done. Yeah, means now. Now, let me open a file here from this thing. I think there's BMI here. BMI. So I don't know if you can see this one now. I just opened the file now. This is the BMI data. What we have group variable here. There is group 1 urban rural. If you see the label, can everybody see urban? If you scroll down, you see rural. It's urban rural is the group. Can you see? And I want to see. It's only that I don't have anything better. I have, let me use sex, urban rural, because the only variable I have here that is the only categorical variable I have here is, we did BMI. Did I save the BMI here? It's obesity, yes. It's okay, we did just put obesity. BMI category, I remove it. There's no BMI category here that I have more than 1, 2, no problem. Let me just run now. If I want to do chi-square, I will analyze descriptive cross-tab sex, I will, even though there, it just says, I want to do category chi-square for the sex, for the two groups. There are two groups here. I just decided to make you, I'm not concerned about percentage here now. I just want to make the group, the column. I just click on chi-square. Every other thing, just leave other thing. I'll just say okay. So he did the chi-square for me. Can you see? He put rural, urban. If it's marital status, there are more categories.
Yes, sir.
Okay, sorry, I have not shared. Sorry, I have not shared. So can you see now? Can you see it? The result.
Yes, sir.
And you will see urban, rural. So you just go and choose. What you don't understand is that the sex you want to compare between two groups is a variable. The group is a variable. Actually, in your work, that group is the major exposure variable, because that's why you are doing, when you are doing comparative study, the group variable is your exposure variable, the major exposure variable. So that's the reason you want to compare many things between them. You get the picture now. But when we are running it, we first of all we just go to data and split variable and say compare group and put group. When you put it like this, you want to analyze it by group. You can just go and run the frequency, run anything I want to run. Let's say about that something and run it. Okay. Please, I mean, we talk later, please. So, I'm in a meeting. So, you see, I want to do the frequency now. The group is not part because I split by group. I don't need to see. If I run this frequency now, I think you can see the screen now. It will do, can you see, it do it, the two group for me. Anything I do, it do it, can you see? I'm running, let me scroll. Can you see? Age, can you see? Age, urban, can you see? Can people see? If you can see, let me know.
Yes.
Age,
Yes,
urban,
yes.
age, urban, rural, under A, can you see? For sex, can you see? Urban, rural. For weight, urban, rural. For height, urban, rural. Everything I do, urban, rural. Even if I want to, if you look at it now, if I categorize the age, whatever, I will still do urban, rural for me once I put that in. So look at the sex now. The sex, originally, the way he did it, sex, can you say male and female? No, it's not this.
Okay.
Yes. Let me go to that sex. After age is the sex urban, rural. Look at it. The percentage he give me now is for urban, 1916, the percentage is total for along the column. The same thing, that's where we harvest it. We put this one on the column for urban, this one on the column for rural, with the percentage. When we finish, we can now go and do the cross tab. In that case, we are not interested in the chi-square we are looking for. You don't bother ourselves with the percentage, you just cast and go on. We can also use WinPepi or maybe StarCap for people to be typing the thing inside. You just type the thing to give it to you. That's just the logic to give it to you. I think that one has answered your question. Because I answered that question.
Yes, I think from what you have said now, it seems that you have to have categorized the group. As in maybe group A or B. Because I can see that you use groups now.
Okay,
your work, you are separated
your work is in
A or B.
Okay, don't worry. You are talking. I will even show you something now. Okay,
I know what I did. I categorized group for the group A, I categorized for the group B, and I was now comparing. But from what I learned now, it is the group that you will have categorized, not the.
How do you compare? Is it and you used to compare it? Okay. Okay, you went to run.
I have group 8 for group 8 for group.
How do you do it?
And I categorize
with your SPSS, with SPSS.
Yeah, I recorded the age for group A, for group B. I separated them. So they are following each other. Age A, group
Okay,
A,
don't
age
worry.
group B.
Don't worry. Okay, don't worry about that one. So don't let us waste time. We'll have your work. Yeah, don't let us waste time with that one because let's go. Because a lot of interlude.
I just wanted to understand the logic because that's the logic for so many other things.
We'll be talking about that later. Let's
Okay.
quickly discuss goodness of faith. Who is okay? Go on, ma. Go on.
Excuse me, sir. If I understand what Dr. Odusholu is trying to say,
yes,
is the what you taught us some time back that when you have two groups and you are entering data, well, in the variable view first of all, it should be in series. It should be, for instance, you enter all of group A, and then you're entering in series. You enter in series, not that you now create two different columns, group A age, group B age.
Yes,
But you enter for each in series, group A, all of them.
You are right. So you are right. That is why you see sometimes when we see before, that was why. Thank God for the malaria consortium people that are in this training. Then, but I would have loved them to have been in the training on using expresses. Because sometimes I know the psychology. Yes. Apart from the fact that some people, they have not downloaded this. Even some people, it's possible some people have downloaded this thing. But they don't want to, nobody want to bet. If you know my pattern, nobody is embarrassed because if I say read, I will tell you what to do. Not that I use it. Look at Dr. Una. Are you still around? She go. Dr. Una. It's like he has logged out too. And she does say is there, yeah. So it was the one demonstrating when last week when we were doing this.
Yes, sir, I'm around, sir. I'm around,
thank you. You know you were around when we were doing the UC Express. It was demonstrating. You see, what you today demonstrated is ignorance of express moving around express environment. It's very, very important. But when we ask people, they don't know that it's something that you need. So I don't want us to go back because if we put a lot of things now on our neck, we will not be able to achieve the aim of this thing. So let's just move forward. If we iron them out. Those are the things. How do we iron them out under the using expression? But we can see the revisiting. That's why I want people to ask questions. People that, like in malaria consultant, you are not asking questions apart from Jane. I don't know why you are not asking questions. Is it that you already know all this? If you already know all this.
The question of chi-square. The chi-square for trend there. So you know the trend can be, I thought the trend can be positive or negative. So and so if for example
positive or
value.
What do you mean by
positive? Okay, let me explain. Sorry, maybe I'm not using the correct grammar. So you know, because
I know what you are saying,
so
but I just want you to use this thing.
Okay, so what I'm trying to ask is when you're interpreting it, I know that if, for example, the P, which is the asimp, if the P is less than 0.04, I'm guessing that means there's a trend.
Yes, now which is what we have now.
Okay, so if we know how to interpret that data, that's how do we say? Are we going to say that? And looking at that result, would that result show us if, for example, with let's say the male, like if I'm trying to remember with the two variables you used, you know, maybe to show us that with increasing educational status, the social, I don't know if you get what I mean. The other one was decreased. Oh.
Okay, I know what you are saying. Don't worry, I know what you are saying. You know, sometimes you may have something you don't know how to express it. I understand what you are saying. I will show you something. Understand what you are saying. Okay, let me stop sharing this. Okay. I just want you to see the result we show for that one again. Yeah, look at the results. So now we have already seen, you can see from the here that is significant because P is very small, less than 0.01. So it already shows you there's a trend, but it's you that we interpret the trend. The trend I am seeing here, we have interpreted it as the education increases, the percentage of people that are employed increases. In fact, trend is the easiest to interpret. Just as the percentage of employment increase will increase level of education. Simple. Simple. Chi-squares or trend is this and p-values is simple. The percentage of increases as this increase. Simple. It can be the other way. The percentage of employment can decrease as the education increases. It's trend. If the trend is positive, it's trend. I don't know if you understand me now. So it doesn't really matter either positive or. So that's just it. Whatever you observe, to be sincere with you, what you know, you don't know that the strategy, just like what Dr. Ikibo was saying something like that. Yes. Before you do your inferential statistics, you have seen this thing. I agree with what he was saying. You say your data, you have done your descriptive statistics. You are seeing, but what you are testing that this thing I'm seeing, is it by chance or not? That's what you are putting to test. You understand me now? If you tabulate your table, you can see the percentage. Look at, can you see? Can you see? It's not the statistic that will tell you, you can see it with your eye. But this thing, you want to see if it's valid. You want to see, okay, let's put it to test. Because it's possible that what I'm seeing is just a chance occurrence. That is the essence of test. You will have done your descriptive strategy, you will have done run your analysis and see your table. So it's not the statistic that give you your table, so you summarize your result. You summarize your result. The statistic is just to confirm some of the things you are seeing. You are observing if it is true or not. So
I have a question.
Yes.
Can you hear me?
Yes, sir.
Is chi-square for trend a counterpart or something that is similar to correlation for quantitative variables?
It's not the same, because when you say correlation,
for quantitative variables
at the different level, where it look like that. You go when they say linearity, it may look like that because in correlation, you are having number as the value of this one increasing, is the value of this one increasing? No, is it increasing? As you know, it's the same thing in somehow, because the trend as the value of education increasing, the proportion that have this attribute, is it increasing or decreasing? As the level of education increases, yeah, it can be like that. But in fact, let me tell you, sir, most of the time, some people after I heard something, this time they may even say correlate. They say they are correlating because in medical researchers, the way they think, the way you think in medical life is different from the way the other people think. What they call what you call descriptive study, they say it is correlational study. But what we call correlational study has nothing to do with what we call correlational study is different. We also call it ecological study. So we don't want to discuss study design now. So the way we perceive things is different from the way some other people perceive things. Before you say correlation, there must be quantity. Though sometimes you are dealing with ordinary variables, so we can talk about correlation. That's why we ask primary correlation. The reason being that even the ordinary, you can score it. So that's why. So this one now can look like a Spearman correlation, the one that is for non-parametric, because in this case now, the level of education, we can rank it. We can give you 1, 2, 3, 4. The proportion that is employed, the percentage of employment, somehow or less, is more like the proportion, the number of people that are now employed in it, the percentage of the one that is now employed is the one that is a little bit
level increases. Yes.
Yeah, but it's dicey because that one it's not like, if you look at it now, the exposure is ordinal, but the outcome is binary. It's not ordinal. Can you see now? The outcome is binary. because that percentage now is binomial. You get picture now because it's the way we already said it has to be binary. So it may be doing something like that, but we don't call it correlation. We don't call it correlation. Or Dr. Ogogore have something to add to that because
no, I was trying to understand what you meant by the outcome is binary. It's not for this, is it?
Look at it, employee, non-employee. Employee, non-employee is
binary. Oh, okay. I see what you mean. Okay.
You are not look at what I said at the beginning of it. When we saw you see, this assessed whether a binary variable varies linearly to the level of an ordinal variable. So it's binary.
So which one is your output is the outcome is usually binary.
For trend, if you want to do, you can only do trend outcome that is binary and the exposure is ordinal. That's what we are saying.
Oh, thank you, sir, for that.
Yes. Okay. Oh, so does anybody want to say anything about that? You can make comments, not necessarily question. But anyway, let's quickly look at what's the time now? Because actually, what's the time?
10 minutes to 9.
Okay. Should we stop here and start earlier tomorrow?
Yes, sir. Yes, sir.
Yes, sir.
Nobody should come and disturb me with downloading, non-downloading, installing, non-installing. Nobody should disturb us with that. I think we have demonstrated how it's only that by that time, I made mistake here. I would have left the. I didn't want. When we start, I actually have the recording so that it will not have just unnecessary. Or in the beginning, try to talk something. Should not be added to the. See, I will have even start with. I don't know if I've started. I think we have started recording. I think we have started recording.
You're still recording now. So are you not still recording? You're still recording.
I know. I said when we were demonstrating the how to.
Did you stop it at any? Oh, you stopped it at some point.
Okay, no problem. If I will check if we have started, you will see the recording there. If we have started recording, the recording. And please, everybody should iron it out. If you have a problem, let me know before the time. So it's not the when we are. To anybody that is not, you have not installed, you won't be able to use it. But I want people to go and install it, and so that I can be home. So I don't know if there's any question. There's no question.
Even the installing you were talking about, it's a learning process for a lot of people.
And that's what I'm saying. That's what I'm saying. I know what I'm saying is that because we have taken a lot of time. We didn't in our timetable. We didn't factor learning installing into it. You get the picture now. So eventually, well, maybe what will happen is that we may not be able to do relative risk on odd ratio. You end it with this one. But it may make sense. The reason, let me tell you something.
It's important to.
What was your own business about that one?
Please. If you let me sit down, I was like,
issue? No.